What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice multiplying binomials using an area model, which is sometimes referred to as the box method. Looks kind of like this here. If this looks familiar, then you're in the right place to practice. And if this doesn't look familiar, then you're about to learn a new method, and you might like it better than FOIL or applying the distributive property. So let's jump right into our first example here. This method relies on a couple of key mathematical ideas. One is that the product of any two quantities is equal to, right? This is the product of two quantities. This is equal to the area of a rectangle where one of those quantities is the length and the other quantity is the width. So in other words, x plus 3 times x minus 5, whatever that quantity is equal to the area of an x plus 3 by x minus 5 rectangle. First key idea. So we're going to find the area of this rectangle. Second key idea here is that the area of this larger rectangle is equal to the sum of the areas of these four smaller rectangles, where this is an x by x rectangle. So technically this is a square. They all kind of look like squares, but they're not. I'm just drawing them that way. So this is an x by x rectangle. This is a -5 by x rectangle, and etc. So the area of this entire rectangle is equal to the sum of these four areas. Visually you can see that. That should make sense. And so what we can do is we can break up this rectangle into these four smaller rectangles and multiply each of these things together, which we sometimes call partial products. And you may have even learned this method when you learned in like 3rd grade how to multiply two-digit numbers together, because this is a method that's also used there. So what's the area of this rectangle? It's x by x, so x squared. So again, it's a square. It has equal length and width. What about this rectangle? Well, 3 by x, so 3 times x. What about this rectangle? Well, that's -5 times x, so -5x. And then this rectangle is -5 times 3, so -15. So what we found is the areas of each of these smaller rectangles, and the area of the entire rectangle is the sum of these, which is x squared plus 3x minus 5x minus 15. Okay, the sum of these is the area of this larger rectangle, which we said in the beginning is the same as the product of x plus 3 and x minus 5. So that's what we just found, and all we have to do now is simplify by combining two like terms. So we get exactly what we would get if we FOILed. So how is this method any better, you may be asking? Well, one, we may be less likely to make mistakes because we're better keeping track of the signs here. I've noticed with students they're less likely to make those sign errors because we're keeping the signs next to those numbers there. So that's one thing. And this also generalizes a lot better than FOIL. FOIL is an acronym that only works for a binomial times a binomial. Once you get to a binomial times a trinomial, FOIL doesn't work. But this area model does. All you do is you add another column here, add another term, and do the exact same thing. Okay, so two reasons. Maybe you just like it better. I don't know. I personally like it. So that's our first answer here. We multiplied and we simplified, and we used an area model. Let's jump to the next example. So here I already have our rectangle drawn out. So the product of these two binomials is equal to the area of a 4n plus 2 by n plus 5 rectangle. And we can split that rectangle up and find the area of each piece. So this is an n by 4n rectangle. N times 4n is 4n squared. This is a 2 by n rectangle, so its area is 2 times n. This is a 5 by 4n rectangle, so its area is, let's see, 5 times 4, that's 20. And the n's chilling out in front. And this is a 5 by 2 rectangle, so 10. Awesome. And here's kind of a shortcut. What we can notice is we know we're going to add all these things up. So in my last example, I wrote all these out. But if we know we're going to add these up, we can combine like terms while we're doing that. We can notice there's a 20n and a 2n, and those are both positive. So together, that gives us 20 plus 2, 22n. And from here, we can actually just go to our final answer, which is what I typically do when I do this method in practice, is I just jump to the final answer and I identify the like terms in here. If you didn't and you wrote out that extra step, totally fine. You can do that and then combine it in the next step, kind of like we did here when we were first learning it. But I think we're capable of doing this. Hopefully this makes sense. We created the box, we drew it out, we multiplied, we combined like terms, multiply, simplify, boom. Next example. Love this example. What do kids always like to do? They like to distribute the square. They like to say this equals 4x squared plus 9. This is wrong, really bad, but very common mistake. Why is this wrong? Well, because what does square mean? It means times itself. And since the square is on the outside of this expression here, what this means is this is 2x plus 3 times 2x plus 3, right? 2x plus 3 times itself. And this is not equal to 4x squared plus 9. Let's draw it out. We have a 2x plus 3 by 2x plus 3 rectangle, which in this case actually is a square. And so here we have this first rectangle, or again, square, 2x by 2x. So that's 2 times 2 is 4. X times x is x squared. Boom, that's the area of this first piece here. Let's move on to this one. 3 times 2x. 3 times 2 is 6. The x is just chilling. Boom. 2x times 3. Well, I already did that. This is just the order's flipped now. 2x times 3. 2 times 3 is 6. The x is just chilling. And 3 times 3 is 9. And now, again, I can combine the like terms in here by noticing this is the only x squared. This is the only constant. But we do have two x terms that we can combine. 6x plus 6x equals 12x. So I'm going to go ahead and write this out. What is this product? It is 4x squared plus 12x plus 9. We have multiplied and we simplified by combining the like terms. All right, let's try one last example. This is your chance to check your understanding. Pause the video, draw out a box, do this on your own. Press play when you want to check your answer. All right, hopefully you did this. Hopefully you labeled, and it actually doesn't matter which side we label 3y squared minus 4, top or bottom. Multiplication is commutative. Doesn't matter what we label that as the length or the width. I'm just going to write it on top because I feel like it. So this is 3y squared minus 4. And then this is 2y plus 1. So we're going to multiply 2y times 3y squared. 2 times 3 is 6. And then we have y times y squared. So there's two ways to think about it. One is that we have y times y squared, which is y times y. So together, we're multiplying 3 y's together, which is y to the third power. That's how I like to think about it, right? This is y times y. We're multiplying another y. That's 3 of them multiplied together. Okay. The other way is thinking about exponent rules. This is a 1, that's a 2. 1 plus 2 is 3. But then you just have to memorize another rule instead of thinking of it just conceptually. Awesome. Next step here. -4 by 2y rectangle. So that area is -4 times 2 is -8. And then the y is chilling out in front there. All right. Now we have a 3y squared by 1 rectangle, which is easy. That's just 3y squared. And now we have a 1 by -4 rectangle. Easy again. That's -4. Here's what's cool about this example. There are no like terms. Here I have a y cubed term, y squared, y, and constant. So the simplifying is already done, or I guess we could say there is no simplifying to do. We multiplied, we've simplified, and now we can write out our final product. 6 times y cubed plus 3 times y squared minus 8 times y minus 4. Awesome. Hopefully this video made sense. Maybe if you didn't know this method, hopefully you learned it. Maybe you like it. Maybe you prefer FOIL or applying the distributive property. Totally fine. That's the cool thing about math. There are a ton of different methods. You can do whichever one you like the best. Hopefully this video helped. Leave comments below, like the video, subscribe, do all that stuff to support me. But most importantly, keep flexing those brain muscles, and I'll see y'all later.